Welcome back to our channel ClassFly community. So today is the lecture 4. Here we will be learning about the Claustus-Mossotti relation. Here we will be doing the definition and the derivation. So without wasting more time, let's begin. So basically Claustus-Mossotti relation is a microscopic property, polarizability, which is denoted as alpha, to the macroscopic property, that is the dielectric constant, that is epsilon r. So the basic relation between Clausius-Mossotti relation is epsilon r minus 1 by epsilon r plus 2 is equal to n alpha by 3 epsilon naught. So we need to derive this equation. So before that, we need to know some basic definitions like dielectric constant. What is the relation of the dielectric constant? That is the epsilon r, and which is a very important property for the Clausius-Mossotti relation as it is with respect to macroscopic property. So it is basically the dielectric characteristics of a material are determined by the dielectric constant. So whatever characteristic of a dielectric is, that means it can be only derived by a dielectric constant. Then the dielectric constant of a medium is basically the ratio between epsilon by epsilon naught, where epsilon is the permittivity of the medium. So it is the permittivity of the medium, whereas epsilon naught is the permittivity of the free space. So this is for medium and this is for free space. Now we come to the point that dielectric constant doesn't have any units, or we can say any dimensions, and we also call dielectric constant as relative permittivity of the medium. So now the second definition is about polarization. So basically polarization means the process of producing electric dipoles which are oriented along the field direction is called polarization in dielectrics. Now basically this statement means that if there is a dipole that is that is plus minus is the dipole, and if an electric field is applied, then this plus minus has a that means this plus minus have a distance which gets occurred, and this is the dipole. That is only being stated that when a dielectric placed in an electric field, the positive and the charge are displaced from the equilibrium position by very small distance throughout the volume of the dielectric. Thus dipoles are produced. Okay, so now this polarization is basically defined as dipole moment per unit volume. So we define a polarization as P equal to mu by V, where mu is the charge, one charge by the difference in two charges, the distance between two charges. Okay, so mu by V, that is dipole per unit volume. Now if there are many molecules, number of molecules per unit volume, so we will have an N. P is equal to n mu. Each has a moment. If all the molecules have a moment, we can also define polarization as this formula 2 as well as this formula. Now the next thing is polarizability. So whenever an electric field is applied to a solid, electric charges are displaced, causing polarization. So we know that how did polarization happen? If an external electric field is applied between the dielectric, so they get displaced to a small distance. So similarly, what polarization do? So polarization here is the electric field when applied to it, there is a displaced causing polarization happens. So the induced dipoles of moment, which is mu, are proportional to the local electric field, that is E of I. So we can state that mu is proportional to E of I, and polarizability is this constant, that is alpha. So if I take this EI, that is the internal field, to down, so we note that alpha is equal to mu by EI. Now the total polarization of the dielectric contains n atoms. So n atoms, we already know this formula which we learnt in polarization. So what we will do, in place of mu, we will write, if I take alpha here and EI here, which is equal to mu happens. So I will adjust this mu value to alpha ei. So we get its P is equal to n alpha ei. Okay. Now main comes is the next, which performs a very most important to derive this Claustus-Mossotti relation, that is the D, E and P relation. D is the electric displacement, E is the electric field, and P is the polarizability. So we know that this is the formula, that D is equal to epsilon naught E plus P. And if we replace this D with epsilon and E, that means this side we will introduce this, and we will take this one to the other side, and P, before what we will do, we will write this epsilon as, if I, this is what, this is the dielectric constant. So if I take epsilon is, if I take this epsilon naught to this side, it becomes epsilon r, epsilon naught. So if I replace this epsilon with this, we get epsilon naught, epsilon r e, and I will take this to this side. So we get P, and we will take common epsilon naught. So this is another formula which we got. So now to derive this Claustus-Mossotti relation, what we will do, it gives a relation between the dielectric constant, that is the epsilon r, and the polarizability of the medium, that is P. Now what we will do, this is a first equation which we have previously got, which we see, and one of the formula which we need to remember is this one, that is EI, that is the internal field, is equal to E plus P by 3 epsilon naught, which is the second equation. Now what we will do, we will place this value of we will place the value of EI here. So a P for EI is equal to P by n alpha. So if I place in here, so it becomes P of n alpha equal to E plus P 3 epsilon naught, right? Now what we will do, now I will move this n epsilon this side. So if I take this, we will get as P is equal to n alpha E plus P by 3 epsilon naught. So now when we will multiply this, we get n alpha E plus n alpha P by 3 epsilon naught. Now what we will do, we will take this whole thing to the other side. So when we will now take common as P, and we get P bracket 1 minus n alpha by 3 epsilon naught is equal to n alpha E. So when we take this thing down, we get P is equal to n alpha E by 1 minus n alpha by 3 epsilon naught. But we didn't get the main formula, which was ER minus 1, that one formula. So we need to derive that relation. So let's move on to the next. Till now you need to remember this formula which we derived. So let's see what we need to do next. But we know that the polarization vector is P is equal to epsilon naught epsilon r minus 1e. So now we will place this one in that place, because that was P E equal to n alpha E. So we will place in this P this formula. So when we place this, so what happens, E cuts over, and we will take this one to this side, we get this thing. Now we will take this one to down, so we get this formula. Now when we will take this one to the other side, and we will take common out, so it becomes n alpha by 3 epsilon naught, and this one we have 3, as here we will be doing, so 3 by I epsilon r minus 1 plus 1. Now we will take the LCM and do the solving portion. You will get epsilon r plus 2 by epsilon r minus 1. Now as we need to derive this formula, so what we will do, we will take this part this side. So what happens, this one becomes the numerator and this one becomes the denominator. So we derive that n epsilon E by 3 epsilon naught is equal to epsilon r minus 1 by epsilon r plus 2. So this is the equation of Clausius-Mossotti equation, and like this you need to derive. So if you have any queries, please comment us down below. Till then, be happy and have a great day.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magaz videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.